I'm Kate Cahey. I'm the PI of this project. Mark Richardson is the project manager, and he's the person behind the organization of the meeting. And we've got just a few remarks to tell you about what the meeting is all about and how to use it. And then we're going to have a lovely presentation from our program manager at NSF, who unfortunately wasn't able to be here today in person. And then we'll have the Chameleon keynote to start things off. So welcome all. So first about the meeting objectives. One objective is to get to know you, our users, and your research. And then the next one is to understand the requirements for research and the educational projects that you are leading. And as you know, this meeting has an AI theme. So particularly, we want to dive deeper into what kind of challenges doing research on AI specifically poses for you. And those could be hardware challenges. So do you need different types of hardware? Are you working, let's say, on confidential computing? As a result of AI, it becomes particularly important to prove that somebody's human, for example, right? So you can't prove that they are not a bot. Are there services that you need? So in other words, is there anything that prevents you from using the system the way that you'd like to use it? And then lastly, is there some forms of support that we are not providing? I would say be creative and be demanding in all of those things. Some of those things, ultimately, we might not be able to provide, or we might not be able to provide right away. Sometimes it takes a few years for us to figure out how to solve some problem or how to answer some requirement, but we would like to know about all of them. Lastly, a lot of the benefit of being part of the Chameleon community is that community and the output it provides, right? So if you have experiments, if you have teaching materials, we would love if you could, or insights or experiences, we would love if you could share it with others. And there are many avenues of sharing. We do user blogs to highlight your research and how people use Chameleon. We provide a forum where you can share digital artifacts for education and research. So we would like to hear from you how we can make it easier for you to share your artifacts that make it easier for others to get a start with their research or help them support their education. And lastly, what are the emergent topics, right? So what are the needs that you perhaps don't have today, but looking down the road, you expect that you might have? Okay, so the meeting is organized to support these objectives, right? To support understanding, again, your needs for research and education. To support that, we're going to have 3 sessions and 2 keynotes, actually. So I'll give a keynote at the beginning, telling you what we're doing in the Chameleon, what we're expecting to do in the next 6 months, and what we're expecting to do further down the road. But then also, looking a little bit at Chameleon community and so forth. And then in the afternoon, we have a fabulous keynote speaker who's working on emergent research topics and also is a Chameleon user. So the purpose of that is to get you thinking about research, all the wonderful things that you could do using Chameleon. But then we also have panels of users telling us about their research and educational projects. And the panels consist of user presentations and then a discussion after that. And then lastly, we're going to write a report. And the way we do that typically is that we have a core writing team, people who will be here talking to you, and then we give it into a public comment for some amount of time for everybody here to comment on that. We were very encouraged by the active participation in report writing from our last workshop. So we hope we're going to do that this time as well, and then we have the final report. And I'm going to turn it over to Mark now to quickly go over the agenda and a little surprise.
All right, thank you, Kate. All right, so quick overview of the agenda for today. Of course, we're going to have the welcome and keynote from Kate and Deep Maria at NSF, and then we'll be going into the panels. These are going to start at 10:30, so we will have a short break right after this first hour. The panels are going to be organized as part presentation and part discussion. So the panelists will come up for each panel. Each panelist will present, and then they'll step down. The next person will go up, present, so on and so forth. At the end of all the presentations, we'll have all the panelists come back up and sit at the front, and they'll be asked, led in discussion by one of our moderators for today. These will be open discussions, so we encourage you to ask questions yourself if you have questions that come up. Of course, we ask that you reserve your questions after the presentations for the discussion portion. But during the discussion portion, we do encourage people to ask questions if you have them. Asking questions, you just need to raise your hand. You'll be called on, and then you'll be able to ask your question. You don't need a mic. There's mics in the roof, so that should be taken care of. So we'll have 3 panels today, and then we'll have our reception after the final panel at 5 p.m. Tomorrow, we're going to be having 3 parallel sessions. So this is going to be Chameleon tutorials taught by Chameleon staff, including myself. And then finally, we'll have our 2 mini symposia led by Freda Fun from New York University, as well as Tanu Malek from University of Missouri.
I just would like to briefly introduce Deep Mehdi, who is Chameleon's program manager, who's a program manager at NSF. Deep has had a fabulous research career and has been instrumental in shaping Chameleon the way it is today, right? So he is our dream program manager who always challenges us to operate a better infrastructure for you. And today he's going to be talking about problems about academic research in AI and how to fund it. Deep, are you there?
Okay. Well, first thing first is that, as you notice, the date I put it is April 15, 2027, which is 1 year from today. It was by mistake, but at the same time, it's probably interesting to think about academic research in the age of AI, what is going to be in the future. First, I want to welcome everybody to the Chameleon User Group's meeting today. I'm so sorry I was not being able to attend in person. This has to do with limited travel budgets we are getting for, attending different events. So at NSF, so that's where it is. And again, I hope we have a good interaction. I will try to, hear back from Kate about what sort of things happen. Those who do not know, Kate and I talk every 2 weeks because I manage the Chameleon project. Those are bigger infrastructure because of the overall budget, where we have meetings, every couple of weeks with different things I manage there. So, I mean, over time, I've been very impressed with where Chameleon was and where Chameleon is right now. So again, to add one more piece of information to that is that I first came to NSF as a rotating program director in August 2018. So that's, all 8 years back almost. And so the Chameleon was one of the projects that was dumped. Well, I would say dumped on me at first when I came because I had no idea. And so I think it was in phase 2 of Chameleon at that time, if I remember. So we have since then gone to phase 3 and phase 4. As a result of believe the meetings I had with Kate on a regular basis, the 2 things I have seen, at a high level. The user supports have improved, and community is using it a lot. And the other thing, good for me to see, what I think is important, is the number of publications using the platform. So that's what I'm going to do. So I have only a few slides. I'm trying to kind of this is still some thoughts in my mind. What exactly should be academic research in the age of AI? Do we have a place and things to do. What do you want to do? So there will be a few minutes at the end for Q&A. So I'm happy to answer any questions what you might have. So just to think about how much does it cost to do something. So if you know the Chameleon platform, actually we are paying Kate $3 million a year for 4 years. So that's a $12 million. Okay, that we're playing. And this is at one level, it looks like, oh wow, that's a lot of money. But at the same time, what we do know is that if we had to do the same thing on a commercial cloud platform, it would have cost us 4 to 5 times. Okay, so that's one important data point to keep in mind. Secondly, platforms like Chameleon and Cloud Lab, which is also I manage, provides what is called known as a bare metal cloud service, which is almost impossible to get from a commercial cloud provider. So that's one thing to think about, in terms of what it is, how much does it cost. Now let me give you the example of ChatGPT, and it's a little bit old estimate. I was trying to get a new estimate. ChatGPT, there is an estimate from I think 2023. They said that per query it costs 36 cents. It translates to you can see what it is. It translates to so, and then $700,000 per day, $255 million per year. Look, for academic research, there's no way we can put $255 million on just one platform, however much the demand might be. On the other hand, besides what it is, I have another bigger slide that we have multiple platform HPCs and including commercial cloud that we provide different things to the community. So recently, by the way, a Texas ChatGPT data center is expected to cost $11 billion just to create it. Obviously, there is a commercial demand for it. So the question is that not only the generative AI is using mega scale compute, but there are different fields, computational physics, computational chemistry, black hole imaging, DNA sequence analysis. All of them are also using, mega scale compute. And many of these platforms are using actually AI also now. There are a couple of things to think about in terms of what it is. For example, we have NSF, not me. I mean, my colleague Jim Donlon manages the AI institutes that we have. AI institutes are, like spanning these different fields that I talked about. Is not just limited to the computer science group, but these are the things that actually generate some very interesting thing about it. So I try to think about what happens to the other mature scientific field. So think about mechanical engineering as an example. Can a mechanical engineering research design a new engine in the academic research lab? Which is probably almost impossible with the amount of funding they get, the hardware and everything they need to be able to create it. So the example I'll give is from a work that's actually 10 years old now. West Virginia University researchers actually, so these are snapshots of what I saw. They did basically looked at Volkswagen and trying to see what is the emission gain from what it is and what they claim. So when they run the test, they found that the gain is not what the Volkswagen claims to be. It was much less than that because they did it on the wild and everything. And then eventually, I believe Volkswagen admitted that they actually fudged their software to show better results, right? As a result of this thing, Volkswagen is forced to recall many cars, and they said that the diesel emission scandal has already cost Volkswagen 25 billion euros. This is the power of an academic research, honestly. You don't have to do something, like I need a lot of compute, or I'm going to be the biggest, car engine or airplane engine you are going to be able to create, do in academic lab. But there are things you can look at to see that how the systems are working. This is what I call is the science of a problem. And you can make a huge amount of impact. This is a very simple example. And for all I know, I believe NSF did not fund this project. They got funding from some small amount, $100,000 or $200,000 worth of funding, and they made a huge impact. So I want you to think about, when you think about academic research in the age of AI, is to look at the problem that industry is not likely to going to look at it. What kind of things you can actually look into and try to address it with the compute and the things what we have. So I'll give you a couple of examples of a project that we have funded at NSF. So to kind of see how the distributed computing sort of works. So we have two platforms. I have a map here. I'll come back to the map in a minute. Is that this researcher was wanted to do some DNA sequence analysis. I think I mentioned in the previous slide here. Yep, DNA sequence analysis, and wanted to see if he could use our funded platform. And so initially he started with CloudLab, which is another platform like Chameleon. And then what he found out, and CloudLab has 3 sites at that time, and it still does, and University of Utah, University of Wisconsin-Madison, and Clemson University. So when I talked to Praveen Rao, the PI, I said that, Praveen, why don't you kind of try to run this on a multiple sites instead of one site to see what happens? And Praveen, who is works in database area, semi-structured data, for example, is not a networking researcher like me, but Praveen came to me and said that, I'm seeing stuff, the data is not pushed between sites when I thought, machines are waiting for data to be pushed between. And then when it came up, we found out that it's not that the link has no capacity between those sites, that this particular problem had some other interesting thing going on. So I connected Praveen with Lisong Su. Lisong Su is a professor at University of Nebraska. Praveen is, by the way, at University of Missouri Columbia campus. And Lisong Su is a professor at University of Nebraska-Lincoln. And those who are not familiar with Lisong Su, he's the co-inventor of Cubic TCP, which is available on all Linux platform all over the world, basically. So and so Lisong is a networking guy. He knows TCP in and out. I said, Praveen, and when to talk to Lisong, I connected, and so this is one of the paper they wrote on looking at what happens to the network infrastructure when they're trying to do they call it a commodity cluster, and they found buffer issues in the network and all kinds of stuff there. And those who are interested, you can actually go download this paper. And so this is way to improve even our infrastructure for what kind of new research can be done and what new did. And among other things, this particular thing, method that Praveen did, and there's another paper, they use Fabric for that platform as well. And what they found out that with this distributed computing, they were able to beat the state-of-the-art algorithm, the way they scheduling it, the different parts of the computer and everything, about 5 to 10 times faster. And this is not a fancy, ChatGPT platform with many, many GPUs, right? And so there are ways we can actually do stuff. We can learn different things about it. I'll give you another example. I don't have a slide on it. One platform we fund is a national deep inference fabric, and that has also at Northeastern University. David Bow is the lead researcher on that one. And they are using the NSF-supported Delta AI platform at University of Illinois and whatnot. And when they're running something on that, they found out that the grace upper thing um, from NVIDIA has issues, that it is not actually doing what it is. So I actually pushed it all the way back to NVIDIA, and they're fixing that problem there. So you can see the different problems that can be solved with what we have in terms of academic research that can lead to, new things, an improvement of platforms and everything. That those who are not quite familiar with, we do fund a lot of research infrastructure and testbed around the country. You can see Chameleon here in the picture, in the cloud bank at San Diego, which I used to manage. Now that's the commercial cloud, now managed by my colleague Bob Chaddock for cloud banks to, 2.0. And we got the fabric on the back end connecting your high performance computing sensors like Frontier in Austin, Exceed, Urbana, now Delta AI is there, and then the wireless platform and everything. So what we are building is that a platform, I would call it, to do distributed AI that you can actually do, and you can do from user to edge to core to the cloud type of end-to-end research on this platform to do things that industry is not actually doing it. So with that, I'm going to stop it here, and I don't know how much time I spend. I'm happy to kind of answer questions you may have.
So Deep, one question from me
Yeah.
is which NSF programs people aspiring to with bright new ideas about both how to use AI for science or make fundamental improvements to AI, which NSF programs should they apply to?
Good question, Kate. I don't know if the all of the attendees there know. Due to the administration directive, AI is a priority area as well as quantum for NSF. So what we are doing is that even like our future core program that we have, that we manage, is that we are, if you have any sort of an ideas, new fundamental research ideas using AI or doing fundamental work in AI, you can submit under that program, for example, right? We also had a Vine's Next Generation Networking program, research program that we're currently in the process of doing the selection for the award. That also, we have seen a lot of projects that has submitted with AI component to it. And so what I suggest is that just because it is not officially mentioned AI anywhere, doesn't mean that we do not, give priority to AI. We do. So any programs you see NSF has, solicitation or open call, please feel free to submit it, put your ideas, and then you'll be able, that can, will help you to be able to fund it in that.
Any questions? Yeah, Valerie.
So my
Hi,
question.
Valerie. How are you?
Good. How are you, Dave?
I'm good. Sorry, to miss you. It's a good talking with you a couple of years back. Go ahead, please.
Yes. So this is really good to see all the research resources and test beds, and they're very much needed. I was thinking about NAIR, and wondering
Yes.
too, is that an avenue also to access the resources here as
That
well?
is correct. Actually, this picture is a little bit older. That's the best one I have ready. So NAIR is, those who are not familiar with NAIR is the National AI Research Resources. It's through a centralized way for the researchers to request it. When they request it, they actually go through they could use Frontera, Delta AI, that we got Chameleon, all of this platform we have. You can also access through that one. You don't have to pay anything to use it. So remember, it's open to you. By the way, Chameleon, you don't pay anything. It's all, even if you do not have an NSF grant, you can use it. So please use that. So yes, you can use NAIR to access it, but also you can directly contact the platforms, Valerie, to request to use resources.
Yeah, Frida.
Yeah. Hi, Deep.
Hi, Frida.
So, as you know, all of these platforms are not only a tremendous resource for research, but also for education.
Right.
And I understand that one of the major ways that NSF tracks the outcomes of these platforms is through publications, which
Correct.
captures the research side. I was wondering if there are any, thoughts about how NSF might start to capture the outcome of these platforms on, impact on human resources and education.
A great question, Frida. So one of the things I did mention publication, but if you talk to Kate, she will know. I've been asking her to say how many different institutions and students are using the platform for educational purpose. I get that data, how many users are from those institutions. Not only that, I have asked recently Kate to provide me data on how many of them are from our two institutions or primarily undergraduate institutions, as well as AppScore State. So we are collecting those data because those are important to show the benefit to the broader benefit to it. Those, metrics are very, very important, not just the publication. In the publication, you're right, only shows the scientific aspect, but that's not only the point of any of this platform. It needs to also train the next generation of researchers and people who will work in industry and whatnot, so that they have the experience and whatnot. So more students get exposed. Frida, you run great classes with way high number of students. I really appreciate that. Those are good thing for us because we can internally say this is what's being used for. And so yes, we do. It does matter. Absolutely. Good question.
Okay, I think we need to move on to the next part of the program at this point. So, Deep, thank you very, very much for sharing your insights with us. If you would like to remain on Zoom and listen to the talk, that is a possibility. We set it up so that you can do that. And of course, ask questions. Keep us on our toes as usual. So, thank
Yeah.
you. Thank you again.
I have another event, but I will probably try to listen to Valerie's talk, being quiet at least, because I have something else to attend to, but I'll put it. Okay, I'm looking forward to hearing about it. Thank you for organizing the user meeting. Really appreciate it.
Yeah.
Okay.
Thank
bye.
you. Thank you very much for your talk again.
Mhm.